So in the previous session, I have covered the theoretical concepts or the theoretical background about generation of word vector. That is one of the popular word vector, that is Word2Vec, which is built upon a skipgram or probabilistic based approach. So in this session, we will have a hands-on or on a live usage of the Word2Vec. So how we use Word2Vec and how we train the Word2Vec and how the results come out. So in this session, I will be dividing with the two approach. One, I will be passing our own text corpus or the text corpus which I have created, and later we will be using a readily available a large text corpus to train the Word2Vec model and see the difference in the performance of the Word2Vec. And one more key point to start again with, we use Word2Vec of size 100. So basically, we start the assumption that we are using a Word2Vec of dimension 100. So the dimension of the Word2Vec would be 100. So the very first thing I need to do is to import the necessary modules from the Python to support the Word2Vec. So I'm going to use NLTK module, and there is a library called gensim.models where the Word2Vec model, like Word2Vec algorithm is present. You can just hover on that and you can just see where this algorithm is, what's the function, or like how it is built, everything. So just tips on that. So I have imported the Word2Vec models. Then I have imported other libraries such as NumPy and plotting in order to see other aspects of the performance of the Word2Vec. So we will first dive in into very first approach, that is creating our own text corpus and train our Word2Vec based on this text corpus. So I have created 5 sentences in this format. You can just have a look at it. Like one of the first sentences, I like data trained. So I have created sentences similar to this. Now I have to split these sentences into chunks or single words. So that's what we will do, right? So that's what we will try to feed word to vec model. That is in other words, what we can say, we will just pass these sentences in the form of words, right? So in other words, we will also convert these words into like vectors or the one hot coded vectors, right? So that's what I am trying to do it here. Here I have initialized a model, and I have mentioned it as a word to vec. And for this, I am passing these word tokens which I have just generated, and I am just initializing this model. Okay, so now I am going to check the word vector generated for each and every word. So as I mentioned in the previous session, like for each and every word, it will be generating a Word2Vec model, right? It will be generating a word embedding. Basically, the word embedding will consist of word vectors or the vectorical representation of the given word. So as I also mentioned, the Word2Vec which I generated will be of the size 100. So there is a function readily available within it. So if you just say model.mv, and if you pass the word for which we want to see the word vector or the word embedding generated, we'll get the entire picture of the word embedding generated. So this is how the word embedding or the word to embedding is generated for this given word ml. So let me check also the dimension of that particular embedding. So it's clearly 100. So now it's time to check out the performance of the Word2Vec, which I have just created or trained based on the 5 different text samples which I have created. So the very first thing we can check about the Word2Vec is the letting know the context words, right? That's what the Word2Vec we use it for. We have to pass a single word, and for that single word we will be getting a output which are contextual terms or nearby terms or the neighboring terms for the given word. So for that we will be using another inbuilt method for that Word2Vec, that is model.wv dot most similar words. So if you just hover on it, you can just have a glance on it as well. So this will contribute the most nearest word or the neighboring words for the given input word, right? So here I am going to pass the word faculty. So the faculty is the word which I have like added in the text corpus in one of the sentence. And also I am going to get only the five context terms or the top five neighboring terms for this given word. So if you just see it, it has given me the output in this way. So the what we are currently seeing is like we are just passing a single word to the Word2Vec now. So the Word2Vec has received this faculty as an input word, and it has predicted these five words as a contextual words. So let me just see whether it has done very well or not. So here you could see that faculty word is present in this sentence, right? So Chidri is that good faculty. Okay, so along with that, it has also continued with the sentence I like ML. Fine. So there is another word already. This faculty is also present in another sentence. Data trained has good faculty. Fine. So by this you can see it would able to identify this contextual terms ML, I, has, like, and data trained as the most nearest contextual words. So in the next session, what I am going to do, instead of a custom or the handwritten text corpus which I have created to train the Word2Vec, I am going to use largely available or a large text corpus present in the internet. I will be taking one of the uh, Wikipedia text compressed into 100 MB, and I'm going to use this text corpora to train our Word2Vec model.